Hello everyone, today we will learn the formula for sine cosine tangent of double angle together. In the previous class, we derived the cosine formula for the difference between two angles and obtained a total of 6 formulas for the sine cosine tangent of the sum and difference between two angles. Let's first review our exploration process in the previous class. Firstly, we know the cosine formula for the difference between two angles, where cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Afterwards, we replaced beta with negative beta and obtained the cosine formula for the sum of two angles, where cosine alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Afterwards, in order to change the name of the trigonometric function, we obtained the sine formula for the sum and difference of two angles using the induction formula. The sum of sine alpha and beta is equal to the sum of sine alpha cosine beta and cosine alpha sine beta, and the difference between sine alpha and beta is equal to the difference between sine alpha cosine beta and cosine alpha sine beta. Afterwards, we used the same angle relationship to obtain the formula for the sum and difference of the two tangent angles by calculating the ratio of the sine and cosine of the same angle. Let's take a look together. Tangent alpha plus beta is equal to tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. Tangent alpha minus beta is equal to tangent alpha minus tangent beta divided by 1 plus tangent alpha multiplied by tangent beta. And we also discussed the need to pay attention to the corresponding small-scale limitations when using the tangent formula. That is to say, we require all tangent values to be meaningful. For example, for the tangent formula of the sum of two angles, we require that the sum of alpha beta and the sum of alpha and beta are not equal to half pi plus k pi, where k belongs to z. After exploring these formulas, today we will learn the formula for doubling angles based on these 6 sum and difference formulas of two angles. Let's first look at the sine formula for double angle. Okay, the first question is there any formal connection between the required sine alpha and the known sine alpha plus or minus beta in this formula? We found that they are all sine waves of angles, but the form of the angles is different. But different forms of angles have inherent connections from the perspective of computation or substitution. Therefore, we can establish connections for conversion based on differences. The second question: can you analogize the exploration process of the previous class and use the sine formula of sum and difference of two angles to derive the sine formula of double angle? Let's first analyze the formal relationship between the sine 2 alpha we require and the known sine alpha plus beta formula. We can write 2 alpha as alpha plus alpha. Also, because the sine formula for the sum of two angles holds for any alpha beta, replacing beta with alpha will definitely hold. In this way, we can use the sine formula of the sum of two angles to write sine 2 alpha as sine alpha plus alpha expansion to obtain sine alpha multiplied by cosine alpha, and then add cosine alpha multiplied by sine alpha and merge to obtain twice the sine alpha cosine alpha. We used the sine formula of the sum of two angles to complete the process just now. If we use the sine formula of the two-angle difference to complete it, the method is basically the same. Just replace beta in the formula with negative alpha. In this way, we obtain the sine formula with twice the angle, where sine 2 alpha is equal to twice the sine alpha cosine alpha, and this derivation process is actually a process from general to specific. In the future, this method will be very useful in trigonometric identity transformations. The third question: can you follow our derivation process just now and use the cosine formula of sum and difference of two angles and the tangent formula of sum and difference of two angles to obtain the cosine formula of double angle and the tangent formula of double angle? As before, after replacing beta with alpha in the cosine formula of the sum of two angles and the tangent formula of the sum of two angles, we obtain cosine alpha. It can be expanded in the form of cosine alpha plus alpha, resulting in cosine alpha multiplied by cosine alpha minus sine alpha multiplied by sine alpha equal to cosine square alpha minus sine square alpha. The similar tangent 2 alpha can be written as tangent alpha plus alpha. Substituting it yields tangent alpha plus tangent alpha over 1 minus tangent alpha multiplied by tangent alpha to obtain twice tangent alpha over 1 minus the square of tangent alpha. In this way, we obtain the formulas for the cosine of the double angle and the tangent of the double angle. Next, if we require the cosine formula of double angle to only contain the sine or cosine of angle alpha, may I ask if there are any other equivalent expressions for this cosine formula of double angle? You may have thought that we can use the sum of the squares of the sine and cosine of the same angle to obtain the same angle relationship of 1. We can then perform a formal equivalent transformation on the cosine formula of the double angle. Let's take a look together. Cosine 2 alpha, according to the result we just obtained, it is equal to cosine square alpha minus sine square alpha. We can write cosine square alpha as 1 minus sine square alpha, so that the formula for cosine alpha becomes 1 minus twice the sine square alpha. Everyone has found that we can change the cosine square alpha, so we can also change the sine square alpha. Similarly, we can write cosine alpha as cosine square alpha, subtract 1 minus cosine square alpha, simplify to get twice the cosine square alpha, and then subtract 1. Okay, that means we have 3 equivalent forms of the cosine formula for double angles. Cosine 2 alpha can be equal to cosine square alpha minus sine square alpha, or equal to 1 minus twice sine square alpha, or equal to twice cosine square alpha minus 1. The above formulas are collectively referred to as the angle doubling formula. The double angle formula characterizes the relationship between the trigonometric function of angle alpha and the 2 alpha trigonometric function. It should be noted that the double angle we just mentioned specifically refers to the double angle. If we encounter nouns such as triplets, we cannot omit them. Okay, for the 5th question, we can use the cosine formula with a twofold angle. If we know sine alpha or cosine alpha, we can calculate the value of cosine 2 alpha. On the other hand, if we know cosine 2 alpha, can we also calculate sine alpha and cosine alpha? Let's take a look together. From the perspective of the equation, we can see that the cosine formula of the double angle has the following equivalent form. We can write the formula for twice the cosine angle as 1 plus cosine 2 alpha, which is equal to twice the cosine square alpha, by transferring terms. Alternatively, we can divide this by 2 to obtain cosine square alpha equal to 1 minus cosine 2 alpha divided by 2. Similarly, for the cosine formula of a double angle, we can also write that 1 minus cosine 2 alpha is equal to twice the sine square alpha, that is, sine square alpha is equal to 1 minus cosine 2 alpha divided by 2. If we need to further calculate the values of sine alpha and cosine alpha, the sign of the square root is determined by the range of angles alpha. Okay, just now we talked about the angle doubling relationship between these two formulas when viewed from left to right. Structurally, it is transformed from sum difference to product. In terms of frequency, it has changed from once to twice. In this way, whether from right to left or left to right, it can achieve changes in the angle, as well as changes in the substructure and degree of the equation. Let's take a look at 2 examples together. The first, 1 plus cosine alpha, can be written as twice the cosine squared by half alpha . In this way, while increasing the number of algebraic expressions, we also reduce the size of the corresponding angles. The second, will everyone ask for a sine square of 15 degrees? Previously, we could write 15 degrees as, for example, 45 degrees minus 30 degrees or 60 degrees minus 45 degrees using the sine formula for the difference between 2 angles. Then square it again to obtain the value of sine squared by 15 degrees. Now that we have the cosine formula for twice the angle, we can write the square of sine 15 degrees as 1 cosine 30 degrees divided by 2. This converts it into the familiar values of trigonometric functions, and it is also easy to obtain the result of 1/2 minus root 3 of 4. Okay, actually, this is also a process of using formulas in reverse. So, the double angle formula needs to be used in both forward and reverse directions, and we need to make flexible judgments based on the solution content and given conditions. Okay, after we have obtained all the angle doubling formulas, let's think about this question. From the derivation process of the formulas for some angle difference and double angle, we can find that there is a close logical connection between these formulas. May I ask everyone, can you summarize the connections between them? Let's take a look together. Firstly, we replace beta with negative beta in the sine cosine tangent formula for the difference between 2 angles, and we obtain the corresponding sine cosine tangent formula for the sum of 2 angles. Secondly, the cosine formula for the difference between two angles and the sine formula for the sum of two angles, as well as the cosine formula for the sum of two angles and the sine formula for the difference between two angles, can be formally converted through induction formulas. The ideas of transformation and substitution were reflected in both processes just now. Moreover, the induction formula can be seen as a special form of the formula for sum and difference of two angles, while the formula for sum and difference of two angles can be seen as a more general form of the induction formula. Okay, next we will replace beta with alpha in the sine-cosine tangent formula for the sum of two angles, and we will obtain the sine-cosine tangent formula for twice the angle. And this is also a research process from general to specific. Okay, for all the tangent formulas that follow, we can obtain them by using the same angle relationship between the sine and cosine of the same angle. The three equivalent forms of the cosine formula with a double angle can also be transformed into equivalent forms with the help of the same angle relationship. Okay, after exploring the logical connections between these 11 formulas, let's think about how to apply them to solve practical problems. Okay, let's take a look at example 1. Example 1, given that sine alpha is equal to 5/13, quarter of pi is less than alpha and less than 2/3 of pi, we require the values of sine for alpha, cosine for alpha, and tangent for alpha. What we know is a trigonometric value of 2 alpha, and what we require is a trigonometric value of 4 alpha. We found that this 4 alpha is twice the angle of 2 alpha. Therefore, we can consider using the double angle formula to solve. Okay, let's analyze the values of these three trigonometric functions one by one. Sine 4 alpha, we can use the angle doubling formula to write twice the sine 2 alpha cosine 2 alpha. Among them, sine 2 alpha is a known condition. Cosine 2 alpha can be obtained from sine 2 alpha through the same angle relationship. Then its symbol is determined by the range of angle alpha. Cosine 4 alpha, we definitely chose the cosine formula 1 with twice the angle, 1 minus twice the sine square alpha. Because we already know the value of sine 2 alpha, we can directly substitute it into this formula to obtain the value of cosine for alpha. Tangent for alpha, we have two ways to answer. One way is to obtain the same angle relationship by dividing sine for alpha by cosine for alpha. Alternatively, we can use sine 2 alpha to first calculate the value of tangent to alpha, and then use the tangent formula of double angle to calculate the value of tangent for alpha. Okay, now let's take a look at the specific problem-solving process. From quarter pi being less than alpha and less than half pi, we obtain half pi, less than alpha, and less than pi, so 2 alpha is a second quadrant angle. Cosine alpha is equal to 5/13. According to the same angle relationship, cosine 2 alpha can be written as the square of 1 minus 5/13 under the negative root sign, which is equal to the negative 12/13. Next, sine 4 alpha as twice sine 2 alpha as we just mentioned. Substitute cosine 2 alpha into the known and solved values to obtain sine 4 alpha, which is negative 120 divided by 169. Cosine alpha, we use the formula of 1 minus twice the sine square alpha and substitute it into the corresponding value to obtain 119 divided by 169. We can write tangent for alpha as sine for alpha divided by cosine for alpha, which is equal to negative 120 divided by 119. Of course, we can also first calculate the value of tangent to alpha. We use the same quantity relationship to obtain sine alpha divided by cosine alpha equals to negative 5/12. Then, using the tangent formula of twice the angle, write tangent 4 alpha equals to twice tangent 2 alpha divided by 1 minus tangent squared to alpha. After substituting the value, the negative result is 120 divided by 119. This question is not difficult in itself, so please think about it. Through this example, do you have a deeper understanding of the multiple in the formula for multiple angles? We found that 2 alpha is twice the value of alpha, which describes the relationship between two quantities. As stated in the formula, 4 alpha is twice the value of 2 alpha, similar to the problem we just solved. In the future, you may see that half alpha can be seen as twice as much as 1/4 of alpha. What is implied here is a concept of substitution. Okay, now let's take a look at example 2. In triangle ABC, cosine A equals to 4/5 and tangent B equals to 2, we require the values of tangent to A plus to B. Let's analyze first. What we require is the value of tangent to A plus to B. You may most directly break down the required tangent value into tangent to A and tangent to B, and then use the tangent formula of the sum of the two angles to obtain the desired conclusion. Compare with the conditions we already know. What we know are cosine A and tangent B, and what we need is tangent to A and tangent to B. Although the names of trigonometric functions are not exactly the same, the angles have a twofold relationship, so we can consider solving them using the angle doubling formula. Okay, let's take a look at the specific problem-solving process. In triangle ABC, we have cosine alpha equals to 4/5, where 0 less than a and a less than pi. We obtained that sine A is equal to the root of 1 minus square of cosine, which is equal to 3/5. So, tangent A can be written as sine A divided by cosine A equals to 3/4. Tangent to A, using the tangent formula of 2 times the angle, write that the tangent A, which is twice the tangent A divided by 1 minus tangent squared A, which is equal to 24/7. Okay, now let's find tangent to B. Since tangent B is equal to 2, tangent to B is equal to twice tangent B multiplied by 1 minus tangent squared B. After substituting the value, we get a negative 4/3. So, tangent to A plus to B, using the tangent formula of the sum of two angles, tangent to A plus tangent to B divided by 1 minus tangent to A tangent to B equals 44 divided by 117. We just obtained tangent to A and tangent to B from tangent A, cosine A, and tangent B, and then used the tangent formula of the sum of two angles to obtain the value of tangent to A plus to B. So please think about it, do we have any other ways to solve this problem? Perhaps everyone has already thought of the tangent to A plus to B we are requesting, which can be seen as the tangent of the angle A plus B, which is twice the angle. So, we can first convert cosine A and tangent B into tangent A and tangent B, then use the tangent formula of the sum of two angles to obtain tangent A plus B, and then use the tangent formula of the double angle to obtain the value of tangent to A plus to B. Let's take a look at the process under this problem-solving approach together. Since cosine A is equal to 4/5 and 0 is less than a and a less than pi, we obtain that sine A is equal to root 1 minus the square of cosine A, which is equal to 3/5. Therefore, tangent A is equal to sine A divided by cosine A is equal to 3/4. Also, because tangent B is equal to 2. Next, let's first solve for tangent A plus B. The tangent formula of tangent A plus B using the sum of two angles is equal to tangent A plus tangent B divided by 1 minus tangent A multiplied by tangent B. After substituting the numerical value, it equals -11 second. So tangent to A plus to B, using a sine formula with a twofold angle, is written as the ratio of tangent A plus B multiplied by 1 minus the square of tangent A plus B. After substituting the numerical value, 44 divided by 117 is obtained. We found that solution 2 has one less computational step than solution 1, but they are both joint applications of the double angle and angle relationship, and these two methods only have different views on the relationship between angles 2A plus to B and angles A and B, or in other words, the order of operation and solution is different. But fundamentally there is no difference. And after completing this question, we also found that the condition of 0 is less than a and a less than pi is implicit in triangle ABC in the question stem, and the conditions implied in triangles of this kind are also worth summarizing for students. Okay, let's summarize today's content briefly. Today we started with the sine-cosine tangent formula for sum and difference of two angles, and obtained the sine-cosine tangent formula for double angle through transformation and substitution. Moreover, three equivalent forms of the twofold cosine formula were derived using the same angle relationship, and explored the logical connections between all the formulas for some angle difference and angle doubling. Then these formulas were applied to solve several practical problems. In solving the problem, we found that the multiple in the double angle formula represents a quantitative relationship. It's not just about 2 alpha and alpha. As long as the angle relationship is met, we can consider applying the double angle formula. The second point is that when it comes to the relationship between trigonometric function names and angles, we should first focus on the relationship between the angles obtained from known angles, and use this to design solutions to the problem. We can convert the problem of trigonometric function names through the same angle relationship. Okay, the third point is that in the process of solving the problem, the formulas for the sum and difference of two angles and the formula for the double angle are not separate. We should select according to our needs and flexibly apply them to solve problems. Okay, that's all for today's class. Goodbye.